Well, welcome to the 50th anniversary of Alan Shepard's flight to the moon. Apollo 14 happened 50 years ago. Hard to believe. January 31st through mid-February. It was, an awesome time. What we're going to do tonight is we're going to look at the February sky so you can go out in your backyard. It's pretty clear tonight. And we're going to talk about some stars and constellations that are in the winter sky that you can enjoy. And then a little ways through the program, we're going to go back in time and look at the way the sky looked on February 5th, 1971. It was on February 5th, 1971, which is tomorrow's the anniversary, that they actually, Apollo 14, landed on the moon. And I think that you'll enjoy that view. All right, so I've got let's see, a couple more people popping in the waiting room, so we'll let those people in, and we're good. Okay, so what I'm going to do now, I'm going to share my screen, and so you're going to see everybody because the way it seems to work the best is if I share my whole screen rather than a tab. So I'm going to share my whole screen here. And so you can see a variety of things there. And then I'm going to go to Stellarium. And can everybody see this, the night sky here? Right? Okay, so that's good. So I'm going to just talk about things. I'll use my pointer to point around what's going on. I'm going to advance the time just a little bit, so you'll see a little motion here. I'm going to go to 8 o'clock. 8 o'clock seems to be a pretty user-friendly time for everybody, and it works very nicely for what I want to share with you tonight as well. So you can see at the bottom of your screen, there's a big red S, and that's just to remind us that we are facing south. So when you go out, wherever you are in your yard, your driveway, face south, and this is what you should see at 8 o'clock at night. So we're going to talk about what I call the uh, winter hexagon. And I'm not the originator of that phrase, but it's the winter hexagon. And we're going to start by looking at Orion. Right here in the middle is the constellation of Orion the Hunter. And if I put up like the artwork, you can see there's the image of the hunter there. And we'll get back to talking about some of the other constellations around it. So uh, Orion has two very bright, prominent stars. It's in general, it's a bright constellation, but in the upper left, as we look at Orion, you see the star called Betelgeuse. And don't say that too many times fast. So Betelgeuse is a red star, and you can kind of see it looks a little reddish. It's what we call a red giant. It's going to be going supernova in the not too distant future, and that could be thousands of years, not too distant future. And interestingly enough, it could have already happened. So in Stellarium, one of the nice features is if I click on something, it brings up a whole bunch of information about it. And right here, it tells me the distance just about 500 light years away, which means when you go out and you look at Orion and you look at the top left star, Betelgeuse, you're looking at the light that left there 500 years ago. So like at the beginning of the 1500s. So that's kind of cool. But all that to say that Betelgeuse could have already exploded and gone supernova, and we may not know about it for a couple more hundred more years. Um, so Betelgeuse is about going to be at the center-ish of our hexagon. Hexagon is a six-sided figure. Uh, a regular hexagon has six equal sides with six equal internal angles. This isn't exactly a regular hexagon, but it does have six sides. Now, if you look at the bottom right of Orion, there's another bright star called Rigel. And maybe you can see it looks a little on the bluish tint side because it is a whitish blue star. It's about the same brightness as Betelgeuse, a little brighter. And if I click on Rigel, we see that its distance is 862 light years away. So it's significantly further away than Betelgeuse, but because it looks as bright or even a little brighter in the sky, that means that as a star itself, it is a lot brighter and more luminous as an actual physical star. And whereas it is showing us the blue-white color, at the moment, it's not in any danger of going supernova. So it probably is burning steadily as we look at it. Whereas Betelgeuse could already have exploded. We don't know. There was an article which I didn't read yet in Earth Sky News about when is Betelgeuse going to explode. I didn't read it yet, but the fact of the matter is it could already have exploded. We just don't know yet. The three stars in the belt, I love to say them. They're very cool names. They're Arabic names, and they're Al-Natak, Al-Nalam, and Mintaka. And Mintaka is Arabic for belt because we know these three stars as being the belt stars. Or if you see these three stars in a row, and they're fairly close to each other, the total distance apart is just a tad over 3 degrees. And so Mintaka means belt in Arabic. So Al-Natak, Al-Nalam, and Mintaka. Then hanging below the belt here, representing typically the sword that would be in a sheath, is the Orion Nebula. And we may take a closer look at that a little later. But okay, so there's Orion. Can't miss it. Facing south, 8 o'clock at night. When you go out when this program is over, look south, and there is Orion sitting right there for you. Okay, Rigel is going to be our first, excuse me, is going to be our first vertice of the hexagon. And then we're going to move up to this star, Aldebaran. Sometimes people pronounce it Aldebaran. And Aldebaran is the brightest star in the constellation of Taurus, the bull. And if I bring the artwork back up here, you can see it's like the first third of the bull, goes kind of back to the bull's shoulders, typically. And you can see this V shape here. It's called the Hyades. And if you have binoculars, by the way, binoculars are a great astronomical instrument. If you have some, use them on the night sky. If you don't have some binoculars, relatively inexpensive compared to a decent telescope, but you can do so much with binoculars. Don't sell them short. And if you look at this area of sky, the Hyades, it has Aldebaran, you're going to see a massive number of stars. It's a star cluster known as the Hyades, represents the face of the bull, and Aldebaran is the eye of the bull. And it also has a color. So Betelgeuse, remember, is reddish, Rigel, bluish white. Aldebaran is orangish in its color. So let me just talk a little bit about colors. Well, what do these colors mean when you look up in the sky? Well, we're all used to red meaning hot, right? So if you are in your car and you want heat in the winter, you turn the knob or slide the slider to red for heat. And in the summertime, it's hot out, you want air conditioning, so you turn the knob or move the slider to the blue because blue means cool air conditioning. Well, in reality, in the physical real world, it's really the opposite. Red is cool. I mean, it's hot, but it's of the hot temperatures, it's the cooler side of hot, if that makes sense. And blue is the hotter side. So those of you who had chemistry or physical science or chemistry in high school, what color did you want your Bunsen burner flame to be? Blue. Why did you want your Bunsen burner flame to be blue? Or even a camping labogas? You want it blue because that's the hottest, the cleanest burning, hottest temperature. When it becomes yellow, I mean, obviously it's hot, but it's nowhere near as hot as the blue flame. Okay, so the order is red is the coolest, and then orange, which is Aldebaran, is a little hotter, and then you make your way to yellow, and yellow is hotter than orange, and then we have like a yellow white. White is kind of a transition color, really. So you have the yellow white, and then white. White is hot, a lot hotter than yellow, and then you have the whitish blue. And now that you're starting to enter the blue side, like Rigel, that's really, really hot. And then now I call it electric blue. It's kind of a deep, almost like a purplish blue, an electric blue color. And those are the hottest stars. So when you look at the color, and take time to notice the color, because a lot of people, you look at the sky, you go out your kitchen door, right? You look up, oh yeah, it's clear. Oh yeah, look at, there's a lot of stars. Isn't that neat? But you need to take time to enjoy the stars. Give your eyes some time, five at least, 10 or 15 minutes is better for your eyes to adapt. And then you'll see more stars, you'll see higher resolution, and you will be able to discern a lot more color. Our eyes have two major types of receptors at the back on the retina. There are rods and cones. And the rods perceive just black and white. They're more sensitive to light and they just perceive black and white. The cones are at the fovea, or the central part of our eye's retina, and the cones get color, but they're not as sensitive. So they need a little time to get dark adapted to be able to discern the color. But if you go out, tonight, tomorrow, and enjoy, look around when it's dark for 10 or 15 minutes, you're going to notice, oh my goodness, the stars do have color. So Betelgeuse, red, is the coolest of the stars I'm going to show you. Rigel is blue-white. It's among the hottest that I'm going to show you. Aldebaran is orange. So it's on the cooler side, but it's hotter than Betelgeuse, and it's the eye of the bull. And right up here, you see this little cluster up there. That is known as the Pleiades. We're going to take a closer look at that a little later. I want to finish the hexagon first. And that is a star cluster on the shoulders, so to speak, of Taurus. And I can teach you a little Japanese, because Pleiades in Japanese is Subaru. And maybe you realize that, oh yeah, if I look at a Subaru insignia or logo, it's got the 6 stars. And that is the Pleiades. This is the insignia of the Subaru. And I've always found it interesting that we have a Subaru riding on the back of a Taurus. I know everybody's chuckling right now. All right. So on my screen, because I have like a control panel, like at the top, I'm not sure that you can see that. So I'm just going to pull down a little bit. I have to bring my next star into view here. So we have Orion. Betelgeuse is sort of in the center-ish of my hexagon. First vertice of the hexagon, Rigel. The second one is Aldebaran, the eye of the bull. And then we pop up here to Capella right at the top of your screen. And Capella is like overhead. So the bottom of the screen, if you will, is like on the horizon. And Capella is like pretty much directly overhead. So the distance from the bottom of your screen to the top of your screen is like looking out to the horizon to looking straight overhead. So when you go out tonight after this program and you look straight up overhead, you'll see a bright star. And that bright star that you're looking at directly overhead is Capella. And Capella is a yellow star. So isn't this neat? We've got 4 colors already representing different temperatures of stars. Betelgeuse red, Rigel blue white, Aldebaran's orange, and now Capella is a yellow star like our sun. Our sun, not talking about our daughter, our sun is a yellow star. Capella is a yellow star. So they're in the same general classification called a G star. Okay, and Capella is at in the constellation of Auriga, the charioteer. I've never really found a good image that I like of any artwork that I like being the charioteer. But Auriga is the charioteer. He's got, a prodding stick or a whip to, the 2 horses that are on the chariot, and he's standing on the back of the chariot. The thing that I like to be able to tell Auriga is, you see there's like these 3 stars that make up a little triangle over here. So that'll also help you know, am I looking at Capella? Yes, you are, because you see these little 3 triangles. And it kind of makes a C, right? You see a nice C here, and maybe with some type of cursive, you've got this hanging down there. Um, you know, so there you go, Auriga and Capella, yellow star. So when you look overhead and you see Capella, that is only 42 light years away. So another thing that I want to share with you and talk about is what we call magnitude. Magnitude is a measure of brightness. So you can see over here in the chart, it says absolute magnitude and magnitude. So what we want to be looking at, and this is an unknown little pinpoint star that you probably actually cannot see in the night sky. It's a magnitude 5.6. Capella, let's go back to Capella. Capella is a 0.05 for all intents and purposes. It's a 0 magnitude. And the smaller the number of magnitude, the brighter the object. So in the general classification of 0, Betelgeuse, Rigel, and Capella are all in the realm of a 0 magnitude, very bright stars. Aldebaran is a little dimmer. It's a magnitude 1 star. Okay, so we've got 1, 2, 3 stars in the vertices, and then we're going to keep coming over here to the left, and which would be towards the east if you're looking in the sky facing south. And we come to Pollux. Pollux is one of the twin stars. And if you know your mythology, what's the twin to Pollux? Castor, Castor, Castor. So we have Castor and Pollux. So I'm just going to click on Castor here. So Castor, and notice the magnitude is 1.9, which is just about a 2. All right. So we have magnitudes 0, a 1, and now we have Castor is just about 1.9. We'll call it a magnitude 2 star. It's only 51 light years away, so not too much further away than Capella is. Pollux is just a little bit brighter, and if we check in there, we see it's a magnitude 1.5, so it's a smaller number than 1.9, so it's brighter. It's the brighter of the 2. And it is the closest of all the stars we've seen so far at a mere 33.78, or we'll call it 34 light years away. And Pollux and Castor, as I said, represent the twins. So there you have the twins of Gemini. That's the zodiacal constellation of Gemini, the twins, Castor and Pollux. So if you remember the twins' names, Castor and Pollux, you may, when you go out and you look at it, and maybe you don't remember, well, Pollux is a little brighter, and you can tell when you look at them, you can see one of them is a little brighter, and that's Pollux. But maybe you remember Castor and Pollux, but you don't remember, Well, which one's the brighter? Which one's which? Well, the way I remember it, assuming you remember Castor and Pollux, Castor is the one closest to Capella because Capella begins with a C, Castor begins with a C. So which one is Castor? The one closest to Capella. And so now you can tell the name of each of the twin stars, Castor and Pollux. Okay, so now we move on to the next vertice of our winter hexagon, and we come down to this star called Procyon. Some pronounce it Procyon. And Procyon is the bright star in the constellation of Canis Major. And notice its magnitude, it's like between a 0 and 0, it's a 0.4. So very bright. All these stars, the nice thing is they're very bright. And this is the closest star yet at only 11, almost 11 and a half light years away. So it's like a stone's, in terms of stellar distances, it's like a stone's throw away, only 11 and a half light years. So let's just talk about that for a moment. What does that mean, a light year? Well, light travels at a specific speed, 186,000 miles per second. And that's like going around the equator of Earth 7 times in 1 second. The moon, a nice number to pick for the moon that I may mention again later when we get to Alan Shepard, it's about 250,000 miles away. The average distance is less, it's like 239, but an easy number to remember is 250,000 miles away is the moon. It takes light 1.25 seconds. So if you went out and you had a laser pointer and you pointed your laser pointer at the moon, be sure there's no airplanes in the way. It's going to take 1.25 seconds for that laser beam to reach the moon. So 250,000 miles in 1.25 seconds, that's pretty fast. Our sun is 93 million miles away. And so when we look at the sun, and by the way, do never look at the sun directly. Okay, you need like number 14 welder's glass or special eclipse glasses. But in any case, the light from the sun left just about 8.5 minutes ago. 93 million miles in 8.5 minutes. That's moving right along. So going that fast, Procyon, 11.5 light years. If I took my laser pointer and pointed it at Procyon, again, make sure there's no airplanes in the way. It's going to take 11.5 years for that beam of light leaving my laser pointer to get to Procyon. And unless you have a really, really, really powerful laser, when it gets there, they're probably not going to see it. I say they, who knows who lives around the planet system around Procyon. Excuse me. Now we come to the star of the show. But first, let me show you. Here's a little hunting dog. Okay. Procyon is the brightest star in Canis Minor, the little dog, one of Orion's hunting dogs. Then the star of the show, right down here, towards the bottom, towards the horizon, again, we're facing south, is Sirius. And of course, I'm serious about that. Sirius is a whitish blue star. It's the brightest star in our night sky in either hemisphere, north or southern hemisphere. Sirius is the brightest star. Magnitude negative 1.44. Let's see what the updated number is here. Negative 1.45. Okay, so it is really, really bright. Notice we are still closer. Look how close Sirius is right here on this line. It's telling us 8.6 light years. Only 8.6 light years away. And again, on the stellar distance scale, it's in our backyard. It's a stone's throw away. We'll say 8.5 light years away. And Sirius is known also as the dog star. It was used in ancient times. Uh, in Babylonia, it was kind of a signal when we saw Sirius coming, it was time to harvest, because as soon as Sirius popped above the horizon, winter was on its way. Not imminent, but it's coming. It's time to, bring in the harvest, so to speak, and reap the crops. So Sirius, as I said, is often known as the dog star, and Sirius is the brightest star in the constellation of Canis Major, the big dog. Okay, so there's your big dog, there's your little dog. Just as an aside, and we're not going to take a lot of time about it, but who knew there was a unicorn in the sky? There's a constellation called Monoceros, which is a unicorn. So between Procyon and Sirius, and this takes a lot of imagination, and they're dim stars too. They're not terribly bright, they're dim stars. But have a look and realize there's a unicorn there. Okay, so we've completed the winter hexagon. We have Betelgeuse, the upper left star of Orion, in the middle-ish of our hexagon. Our first stop, first vertice of the hexagon, Rigel. We went to Aldebaran, or Aldebaran, which is orange. Capella, yellow star. Magnitude 0, Betelgeuse, Rigel, Capella, all about the same brightness, 0 magnitude, different colors. So you can compare them easily because they are about the same brightness. Then we have Pollux, Procyon, and Sirius. So there's your winter hexagon. I have a few more things to say about this, and then we're going to jump back 50 years. So let me just pause for a moment and ask if there are any questions. Unmute yourself, and one at a time. Does anybody have any questions about the winter hexagon? Okay, I guess there's no questions, or you're bashful. So that's fine. There'll be other opportunity for questions. So one of the things that I just wanted to show you, two things while we're here in this sky. I mentioned to you the Orion Nebula that is hanging below the belt of Orion right here. And let's see if I can zoom in here. If we can get a closer look. Isn't that cool? So that's what's sitting there, is the Orion Nebula. And you can see this with binoculars. Now, with binoculars, it doesn't look like this. And also, uh, unless you have a decent sized telescope, you're not going to see the color, but you will definitely see, and you can just barely perceive it, like just with your eyes. You can tell, I think there's something fuzzy there. And this is a birthplace of stars. The Orion Nebula is, sorry about that, it's a birthplace of stars. And binoculars will show it up, you know, pretty nicely. So that's something to look at in the night sky. And then I mentioned to you the Pleiades. So let's just jump over there on the other side of Aldebaran. Notice that the three stars of Orion's belt, Al-Natak, Al-Nalam, and Mintaka, kind of point upwards to Aldebaran. Keep on going, you bump into the Pleiades, which is like a tiny dipper. Sometimes it's called the Seven Sisters, though most people can only see 6 of the 7 sisters. But we're going to zoom in on this. And so look at that. Isn't that very cool? And you'll see something like this with binoculars. So again, very worthwhile investment to get some binoculars. So these are the Pleiades. And you got 1, 2, 3, 4, 5, 6 stars that show up. Some people can discern or resolve these two stars and see all seven. I hear that like out west where the skies are darker and clearer, that it's easier to see all seven. And some people see more than seven, I'm told. I've never experienced that. But you should be able to count six stars with your eyes. And that's like just a great star cluster and very enjoyable to look at through binoculars. Okay, so those are a couple of, I think I would call them exciting features in the night sky. All righty, so what I'm going to do now is I'm going to stop sharing this screen. I'm going to see all of you. We'll just take a moment, see if there are any questions, and then I'm going to show you uh, something else. We're going to start to talk about Alan Shepard and the sky that was that night that we could go out and see. All righty, so let me stop sharing.
Dave,
Okay, does
Dave,
anybody have any questions now that anybody would like to ask?
Dave.
Yes, George.
This is George DeZuna. Can you hear me?
Yes, George, go ahead. I can hear you.
On the Pleiades, okay, when the six stars or the seven stars that are there,
Yes.
are they the farthest away in light years?
Oh, no, that's a great question. Very good question. No, I mean, they're far away. They're in the order of 400-ish light years away, which is, it's pretty far, obviously, not quite as far as Betelgeuse and Rigel. Uh, but there are objects or star clusters that are a lot further away. And I don't know if you noticed the color was kind of bluish. So they're young and hot stars. A lot of globular clusters, which would be another topic for another time. A lot of globular clusters tend to be on the reddish, orangish side because those are older stars and typically born, so to speak, around the same time. So globular clusters are kind of on their way out. Hot blue star clusters like the Pleiades are relatively young. They're on their way in and they should be around for a long time.
Thank you. Thank you.
You are welcome very much. All righty, so I'm going to change my screen just for a moment. I'm going to share a different screen with you. Let me get that ready for you. And we're going to talk just a little bit about Alan Shepard and company. All right, so I think that's ready to go. All right, so let me just take another quick sip of water here. And I'm going to share my screen again. And hopefully you can see that. And I'm going to present the whole thing. Okay, so everybody good? See that okay? So we've got, I don't know if you see, do you see the people? Can you see the whole Apollo 14 50th anniversary? Yes, no?
Yes.
Okay.
Yeah.
All right.
Yep.
Because in my view, like I've got that list of, well, images or names over it. So I just want to be sure you can see the whole thing. So yeah, so we're the Apollo 14 50th anniversary, January 31st, like just beyond the first week in February to February 9th, 1971. And what a great time that was when Alan Shepard, who was the first American to go into space at all, born in Derry, New Hampshire, went to Pinkerton Academy. You probably know their mascot. They're called the Astros. And born in Derry, New Hampshire, Alan Shepard. And so here's the guys: Shepard, Rosa, This guy is Rosa. He was in the spacecraft orbiting the moon. And so these are the three guys. Alan Shepard is in the middle. And this was the blast off. This whole thing is the Saturn V rocket. And if you can just see this very little bit at the top, this is like the escape rocket. So if there was a problem, that relatively small but powerful rocket would pull the space capsule off the top of the rocket and bring it to safety, where it would come down in parachutes if there was a malfunction with the rocket. So the good thing is, unfortunately, we had the Apollo 1 fire on the launch pad. It was just testing equipment, but bad things happen. But apart from that, the Apollo program was very successful, and no significant mishaps and no malfunctions with the rockets. So these huge rockets brought us to the moon, the Saturn V rocket. So these are on the left, actual photograph of the Antares. So the lander that landed on the moon from Apollo 14 was called Antares. And here you see the base kind of draped in gold foil, pretty thin stuff because there's no atmosphere, from Earth to the moon and on the moon. So you didn't have to have a lot of thick steel. And then over here, this is not a photograph taken by Apollo 14, but this was seen by many of the astronauts that went to the moon, of which there were 12 that landed and walked on the moon. And this is the famed picture of our Earthrise over the horizon of the moon. Very cool. This is Alan Shepard planting the US flag on the surface of the moon for Apollo 14. So you can see these red stripes on his helmet and his arms and his knees. And so they were colored stripes to designate. So when you took a photograph or it was a video, and back then it was like, VHS quality or worse. So when you took pictures, you could tell what astronaut they were because you couldn't see their face, obviously, through the gold foil visor. So they had different stripings, different colors, so they could identify what astronaut they were. And down here, you see, this is also Alan Shepard in this photograph, this black and white photograph. Oops, let me just get back to that again. And this is like an instrument cart that he moved around the surface of the moon. It had various instruments on that he would either use and put back on the cart, or some instruments were taken off the cart and just kind of set up to be there and to stay there. Alan Shepard, at the time of Apollo 14, I'm not sure if the record was broken since, for walking 9,000 feet, which, we're getting close to 2 miles. That's pretty significant, I think, walking on the moon for almost 2 miles. Now, later missions, actually starting with Apollo 15, 16, and 17, they had the rover, so they definitely traveled further because they had wheels. I don't know if anybody beat the walking distance of Alan Shepard at 9,000-ish feet. And then Apollo 14 landed here. So when you look at the moon at night, you'll see, and again, binoculars are such a great help here. You will be able to see the crater Copernicus. And so underneath Copernicus is where Apollo 14 landed. You can see all the other landings. The first landing, Apollo 11, right here in the bottom left, if you will, of the Sea of Tranquility. The last mission was Apollo 17, right here, and the kind of the bottom right of the Sea of Serenity. But Apollo 14, that we've seen these pictures with Alan Shepard and crew landed right here, just south, lunar south of Copernicus. Easy, there's a lot of ejecta coming out of here. So with binoculars, you can pick this crater out and you can say, oh my goodness, that's where Apollo 14 landed. That's where Alan Shepard went golfing on the moon. So let's see if, I don't know if this is going to play, if you can see it, if you can, well, I think you'll be able to see it. But, and obviously the video quality is very poor, because they didn't have the, you know, the CCD chips that we have now, high resolution. There were like 3 tubes, Trinitron tubes. And let's see and listen. Hopefully you'll be able to hear it also, okay?
They got more dirt than ball this time. More dirt than ball. Here we go again. That looked like a slice to me, Al. Here we go. Raise the die. One more. Miles and miles and miles.
So there you have Alan Shepard golfing on the moon. I'll play that one more time for you. So it seems like he actually hit 2 golf balls. The first golf ball that he swung, and he's using one hand because of his spacesuit. It just was not convenient to be able to like use 2 hands with a typical golf swing. So he's kind of swinging with one hand, and he's using an instrument piece with a golf head. I forget whether it was a number 2, number 8, I don't remember. But he brought a golf head and he screwed it or attached it somehow to a piece of instrument that was already scheduled to be on board. I don't think they knew that he smuggled a golf head on there. But so anyway, the first swing was a whiff as far as I can tell. And then he hit it, and then you'll see him drop. You'll see the little white golf ball, which was, I think, his second contact. So I think he hit 2 golf balls on the moon. So we'll watch this one more time.
They got more dirt than ball this time. More dirt than ball. Here we go again. That looked like a slice to me, Al. Here we go. Raise the die. One more.
Miles and miles and miles. So just today, I was talking with somebody, and they thought, well, the golf balls, they went in orbit, of course, because there's no gravity on the moon. That's not true, but a lot of people think that there's no gravity on the moon. Well, if there was no gravity on the moon, they wouldn't have been able to land on the moon or walk on the moon. The gravity on the moon is about 1/6 of the gravity here on Earth. So if you are a person that weighed 180 pounds on the moon, 180 divided by 6 is 30. So if you weighed 180 pounds on Earth, on the moon, you'd feel like you only weighed 30 pounds. So you'd be able to jump higher and run faster. So here we have the capsule, the Apollo, and this is the Apollo 14 capsule splashing down in the Pacific Ocean and to be rescued, which it was by the ship. And so check out starhop.com, and obviously I assume that's how you got here. But there's more programming to come. There's Superstellar Friday tomorrow night and other programs coming up. So check out www.starhop.com for more Apollo 14 programs as we celebrate the 50th anniversary. All righty, so let me stop sharing and pause there. Any questions or I got one more thing. We're going to go to the night sky, the way it looked on the night of February 5th when the Apollo 14 spacecraft landed on the moon. All right. Anybody questions or comments at this point?
Dave,
Yes, George.
this is George again. I know there's many different spots where the lunar landings went, okay? And
Yes.
they picked them spots out for a specific reason. You know, but did they have to change the because the topography of of where they're landing was different? Did they have to change that lunar landing in any way up from the different sites where they landed?
That's a great question. And I think one of the best illustrations to answer your question was Apollo 11. Apollo 11 was the first landing on the moon. And you remember Neil Armstrong and Buzz Aldrin. And Neil Armstrong was the pilot of the lunar lander, the lunar excursion module we called the LEM. And I'm sure you can Google and find the video clips. But that was exactly like what you're talking about. So the guidance computer, everything's programmed because with the knowledge they have, they know where they're going to land, and so they tell the computer, okay, let's land here. But as they're landing with Apollo 11, Neil Armstrong is like, no, that's not a good idea. So he disconnected, so to speak, the computer and flew it manually. And you can hear Buzz Aldrin also shouting out the fuel because there's only so much fuel, and they were beyond the point of being able to, head back to the mothership, if you will. So with, I think it was like 2 seconds of fuel left, they landed. But anyway, Neil Armstrong manually flew the LEM over boulders that he said were the size of houses. And so, yeah, to answer your question, they had to make some guidance changes, and he manually, being the great cool-headed pilot that he was, test pilot, landed them safely, and the rest is history. So exactly what other types of maneuvers were necessary in the other missions, I'm not aware, but they all had the capability to fine tune it at the end. Like if the computer was going to put them down on a boulder, they had the ability to, to steer clear and to land long or short or to the left or to the right. Did that answer your question, George?
Yeah, yes, thank you. That's a great answer because I forgot that he actually was within 2 minutes of running out of fuel.
Oh, well, 2 seconds.
Oh, I mean seconds. That's what
Yeah, 2 seconds. I mean,
that's
talk
great.
about calling it close, right? Okay. Any other questions?
I
I'll have
have,
one. Go ahead.
my son was curious as to how you fit the lander into the rocket, how they build it in when they build
That,
the rocket, fit the lander in.
yeah, I understand. That's a great question. I wasn't prepared. I mean, that is a great question. So I don't have a slide like handy. Well, maybe I can. Let's go back, see if I can answer that for you with at least a little bit with this. I got to go back a few slides here to the one with the blast off. Okay, so this might help. Are you Luke?
Yes, I'm Luke.
Okay, so right here, this little tiny piece that kind of looks like a little triangle, that's the crew, and that's the only piece that came back that we saw splashing down in the ocean. That's all that came back with the 3 members. And then we have here what's called the service module that has like the powerful rocket engine to kind of do the last piece of getting them to the moon, and also getting them out of lunar orbit. Okay, part of the service module, and that's the engine if you ever watched Apollo 13, that's the engine they had with them that they decided they were not going to try to use because they didn't know if it was damaged or not. And then this area here, if you can see my pointer, okay, this area here, that's where it was stored. And so what they did is they disconnected and they took the service module here, okay, which again has a rocket engine in it, and they separated right about where this line is, where my pointer is, okay, they separated, and then this part here, the command module with the service module, went out and turned around and came back to this container, I'll just call it a container here, where that lunar lander was brought up. That's where it was stored, and they extracted it out of its container. So then you have the command module with the lunar lander that landed on the moon attached to each other, and in between the attachment point is a hatch so they could crawl. I think crawl is the right word, or float, crawl or float from the command module to the LEM, or from the LEM to the command module. And you see that happen quite a bit in the Apollo 13 movie. So that's a great question. But this is the area here where that was stored, right in here.
Thank you. That was very helpful.
Well,
And also very cool.
Good. How old are you?
I'm about 8.
Eight's a good age. I was 8 once.
I turned 9 in November 14th.
Awesome. Well, thank you. Okay, so we're going to go back to Stellarium, and I'm going to show you, we got maybe another 5 minutes. I know it's 8 o'clock now, and we'll maybe another 5 minutes. I'm just going to show you the night sky the way it looked from Earth, from New Hampshire, on the night of February 5th, 1971. So I think that you'll enjoy this. Let me see if this is going to work. Okay, so you can see the stars, I assume, everybody. So I'm just going to move the time down here, and we're going to go to 1971, which is very cool. And we're going to, that's February, we're going to go to the 5th, February 5th, and here we are. So this is the way the sky looked. And this is so cool because look at this. We talked about the winter hexagon. Right here is Orion, and above Orion, kind of making a triangle, you got Aldebaran. Actually, this is really cool. I'm just noticing it right now for the first time. You almost have a square, right? Beetlejuice, Aldebaran, Capella, and Pollux. Almost a square with the moon in the middle. Very cool. So if you were out on February 5th, 1971, and you were looking at the moon, you were watching Alan Shepard and his crew land, orbit and land on the moon. So let's see. Well, it looks like a full moon, but it actually wasn't quite a full moon that night. We're going to zoom in on it. The moon that night looked like this. So if you had your binoculars, this is what the moon looked like February 5th, 1971, above Orion. And here's that Copernicus, there's that crater, and they landed right about here. Now this looked like a little bit of a white spot somewhere right around in that area where my pointer is. That's, can you imagine having binoculars and knowing and looking, or a telescope, and you're looking at the moon on February 5th, 1971, and you could see it right, I mean, you couldn't see the spacecraft, but right there, that's where history was made from New Hampshire. Alan Shepard, Derry, New Hampshire, lands on the moon with Apollo 14, right here. And this is the way the sky looked that night. It was like a waxing gibbous moon, kind of looks a little hunchback, thus the name gibbous. So each night it would become fuller and fuller as viewed from Earth. And right above Orion, the winter hexagon, Betelgeuse towards the middle, Rigel, Aldebaran, Capella. I don't know why the name went away. Pollux is here. And then Procyon and Sirius. So there's the winter hexagon. Notice the planet Saturn was in the sky. I don't know if you noticed, I didn't point it out, but when we were looking at tonight's sky, Mars was there. But in 1971, Saturn was in the area. So you could look at the planet Saturn. Okay, this is my last pause for questions. Anybody have any questions about the 1971 sky of Apollo 14?
My daughter Laura has a question.
Okay, that's great, Tim.
Laura?
What's the green star?
Kind of to the left of the moon there, Cancrids. She's
This
curious
one
about
here?
that.
Okay. Yeah, Delta Cancrids. So nice of you to notice that. That's not something that I intentionally have showing. It just kind of showed up. That's actually a little bit of a meteor shower happening there, the Delta Cancrids. And that's a meteor shower that is in the constellation of Cancer. So you see here, here's Orion. We have the twins, Gemini, and then Cancer and Leo. Cancer is the crab between Leo and Gemini. And I'm not sure what the date is because, again, I wasn't planning on specifically mentioning that tonight. But there's a meteor shower that happens at that point as the radiant from the constellation of Cancer. So very observant of you to notice that. But that's the name of a meteor shower.
Thank you.
You're very welcome. Other questions?
Yeah, can you hear me?
Yes.
Yeah, my daughter Olivia wants to know if you can zoom in on Saturn to see what it looked like.
Oh, that's
closer.
sure. What a great idea. Absolutely. So let's bring that to center and zoom in on Saturn. Let's take a look at what Saturn looked like that night. Isn't that cool? Now it's moving kind of quickly here because time is marching on. So I'm going to try to stop. I'll move it back a little bit. Okay. So yeah, so Saturn would have looked just like this on that night. This is the largest moon of Saturn. It's the second largest moon in our solar system. It's the only moon we know of with a substantial atmosphere. It's not a breathable atmosphere, you know, like oxygen. It's mostly methane-oriented atmosphere. But Titan is the largest moon. Here are some of the other moons that you can see with a small, moderate type telescope. Enceladus right here is a moon of Saturn that we know has ice oceans, and it actually spits geysers of water. Liquid water are spewed out of its surface into space, and they quickly crystallize, but we know there's liquid water there, and someday we'll visit there, and somehow the objective would be, can we drill down through the ice to get to the water and see, is anything swimming around in there? So, hey, great request. So that's what Saturn looked like with its moons on.
Thank you.
Oh, you're welcome. I'm glad there's so many kids along with the adults here to enjoy it, because it's history. You know, I teach astronomy and STEM stuff at Belmont High School, and it's not, just high school students in general just don't know of all the neat stuff that happened. So I do a study with them about the human space program, because so many people are just so unaware of the neat things that we accomplished as human beings, as Americans. All right, so any other thoughts or requests that anybody has? I'm going to stop sharing then. We're just going to bring the sky back here. So again, we're going to leave February 5th, 1971. It was a nice night. But hopefully you learned some neat things about the night sky that you can go out. I think it's clear right now. You can go out now and test yourself. Can you find the winter hexagon? Starting using Orion. And you can star hop, get it? Star hop using Orion, STARHOP.com. It's not a coincidence. All right, so that's my presentation. Thank you all for coming. And I hope that you have a good rest of your evening and happy hunting in the sky. And again, don't forget to visit starhop.com. We have more great Apollo 14 50th anniversary programming coming up. And keep an eye on our website because we're going to be opening our doors again soon for you to come and be in person and enjoy all the neat things that we have to share.
Thank you.
Thank you very much.
Thank you, Dave. Great job.
Well, thank you. That's very kind of you.
Thank you, Dave.
You're welcome. Okay, we're good. I'm going to stop recording.
Thank you, Dave.
You're very welcome. Thanks for coming.
Super.
Excellent.
Wow.